Now let's see how you can use the mean value theorem to bound a function's value based on some information about its derivative. Here we have an example where f of 5 is 7, and we know that f prime of x is greater than or equal to 3 for all x. And we want to know what we can say about f of 11. So the idea here is to basically take the right hand of the mean value theorem and to first of all kind of build a quotient that looks like that. In this case, since we know something about f of 5 and we're asking about f of 11, we're essentially going to use a equals 5 and b equals 11. So we start by saying we want to know about f of 11 minus f of 5 over 11 minus 5. We know that that has to be equal to f prime of something. Now I don't know what f of 11 is, but I know that f of 5 is 7, and well, 11 minus 5 on bottom is 6. So all of this stuff is equal to f prime of c. And well, I don't know what the c value is, but I know that no matter what, f prime is going to be at least 3. So in fact, f of 11 minus 7 all over 6 is greater than or equal to 3. Now let's just rearrange that. If I multiply both sides by 6, we get that f of 11 minus 7 is greater than or equal to 18. And so f of 11 is greater than or equal to 25. Okay, so the fact that f prime was at least 3 means that your function has to grow at least at a certain speed. And so going from x equals 5 to x equals 11 involves, in this case, increasing from y equals 7 to at least y equals 25. Let's look at one more example. It comes from a physical problem. So let's say that you have a tank of water holds 120 liters at 1 p.m. And let's say that water drains out of the tank at a rate of, let's say, 3 liters per minute or more. What can you say about the volume of water in the tank at 110? And this is a little bit silly almost, because you really don't need calculus to solve this problem. I mean, you start off with a tank that has 120 liters in it, and you're having some water sort of flow out at a rate of at least 3 liters per minute. And so after 10 minutes, well, we don't know exactly how much water is left, but I know that I've drained out at least 30 liters, right? That's 3 liters per minute times 10 minutes. And so I know that I have at most 90 liters left. Now, I didn't use the mean value theorem explicitly, but that's essentially what's going on. And let me show you how you could set this up formally, not because you need to set a problem like this up formally, but because it helps you to understand what was going on in the previous example we were looking at that was kind of abstract. So one way of formalizing this might be to say, let's let f of t be the volume in the tank, say t minutes after 1 p.m. So we were told that f of 0 was 120. And saying that water is draining by at least 3 liters per minute, well, first of all, that's a statement about the derivative of f. I have to be a teensy bit careful about this. So the proper way to express this is that f prime of x is less than or equal to negative 3 for all x. So less than or equal to negative 3. It could be negative 3.1 or negative 4 or negative 10. It has to be negative because I'm losing water. And so this less than or equal to means that I'm, sort of more negative than negative 3. And then the question is, what is f of 10? Or what can you say about f of 10? And so if I were to set this up the way that I set up the abstract example, I'd say, well, you're looking at f of 10 minus f of 0 over 10 minus 0. That's going to be equal to f prime of something. So f of 10 minus 120 over 10 is f prime of something, and that something is less than or equal to negative 3. Multiply both sides by 10, and you get that f of 10 minus 120 is less than or equal to negative 30. And now add 120 to both sides, and you get f of 10 is less than or equal to 90, which is exactly what we had before. So what this means is that when you have an abstract one of these problems like we had before, if you want to, you could take a problem like this and actually think about it in terms of a tank of water, for example. I mean, maybe that seems a little bit silly, but you could say, like, okay, this is saying that at 105 that I have 7 liters of water, that this is saying that I'm adding water into the tank by at least 3 liters per minute. And then this is asking about what the volume of water is at 111. And you can probably reason about this without really using the mean value theorem. That nice thing about the mean value theorem is that it says that this kind of intuitively obvious idea when you're talking about tanks of water, that it works for any function that is continuous and differentiable, regardless of what the actual physical interpretation is. Okay, and we're going to see some more applications of the mean value theorem in some later sections.